morning once again, good evening, good afternoon, depending wherever you're watching on the globe. We have embarked with our virtual practical class, but today we are just going to look on the how to calculate water of crystallization in some salts. For example, you can be asked in some questions to calculate water of crystallization in copper 2 sulfate salt, or you can be told or either to calculate the water of crystallization in cobalt chloride paper, in cobalt chloride salts. So in this case, we are going to calculate. We are going to calculate water of crystallization. Water of crystallization in cobalt chloride salts. You have been given, for example, you can be told it is X water of crystallization. That's how it is written. This dot must be there. So, in this case, we must consider some factors. Like, for example, we must be able to know the mass of, because in this case, we are using a crucible to handle our salts. For example, we can say the mass of crucible, is equals to, let us say in this case we are going to get the mass of crucible, we record it there in terms of grams, and also we are supposed also to get the mass of hydrated salt, which is cobalt chloride salt, plus the crucible. Which is equals also grams. Also, we are going to record them in grams. And also, we are supposed also to record the mass of. This is the mass of crucible plus the hydrated salt. And also, we are supposed also to get the mass of crucible plus anhydrous salt. Mass of anhydrous salt plus crucible, whereby we are also supposed to record them in grams. So in this case, let us just assume that we have gotten 17.265 grams, and the mass of hydrated salts plus crucible, we have gotten it to be 18.438. And then the hydrous salt, after now we have heated this salt, it will lose its water of crystallization. We have heated that, we have taken that crucible plus the salt. Now we have taken it under the Bunsen burner. So we are heating it. So in the process, that water of crystallization, it will evaporate. And in the process of evaporation, then the mass of this salt will reduce because it has lost its water of crystallization. And therefore, we will get anhydrous salt plus crucible. And the mass, let us now assume that we have found it is around 17.906 grams. So we need to calculate the mass of cobalt chloride plus X water of crystallization. So we come here and let's say calculation of mass of cobalt chloride salt plus X water of crystallization that evaporated. It's going to give us, we are going to write cobalt chloride is equals to. So now we are going to take the mass of the crucible, the mass of the crucible plus anhydrous salt, which is 17.906 minus the mass of crucible here, which is 17.265. And if you do your calculation properly, it's going to give you here, it's going to give you 0.641 grams. Then the mass of water, if we need to calculate now the mass of water, the mass of water is equals to 18.438. I don't have a calculator, that's why I'm just trying to explain it on that body. This is the 18 that I'm talking about. This is the 18. The mass of hydrated salt plus crucible is equals to 18.428, and then we minus 17. We minus anhydrous salt plus crucible, which is 17.906. 17.906. 17.906. So it's going to give us 0.532 grams. So now in this case, we are going to also now to consider the mole ratio. So we just write here cobalt chloride if we want to get the grams here, the molecular mass, the mass of the cobalt chloride, we are just going to calculate it this way. Cobalt chloride is equals to mass of the chloride divided by what? The R, the molecular mass. The molecular mass. If you do a substitution clearly, we are going to take this 0.6. Where is it? In 0.6 grams. This is the mass of cobalt chloride. 0.641 grams over the molecular mass of cobalt chloride. It is 129.9. If you do the relative atomic mass of each, you will arrive at this. So this one is giving us 0.00493. Then water is equals to, we are just following the procedure from the above. Mass of water, and then we divide it by the molecular mass. If we do our substitution clearly, we take this mass of water 0.532 over the relative molecular mass of water. This is 16 plus this 18. So if you do your calculations clearly, you are going to get this one. You are going to get 0.0295. So after we have done that, therefore we are going to take each. Now we consider the smallest value between these. So between 0.00493 and 0.0295, it is 0.00493 is the smallest. So we are going to take cobalt chloride, the mole ratio, we are going to divide it by 0.0 divide by 0.00493, which is going to give us 1. And then the other one of water, the other one of this water, we are going to take it to be 0. We found it to be 0.00295 over this, because we are dividing everything with 0.00493 because it's the smallest value. 0.00493. If you do your calculations properly, you are going to get something to do with the 5.995, and which is an approximation rounded up to 6. So for those few remarks, we have found that the water of crystallization here X, therefore X water, X molecules is equals to 6. X molecules, therefore X molecules is equals to 6. So in this formula, now we are going to write cobalt chloride. This dot means the number of crystallization, water of crystallization in this compound. It's supposed to be written now like this, the final formula. For those few remarks, remember to subscribe, to share, and also to give some comments down the video. Otherwise, thank you in advance, and we shall be meeting you next time in the next virtual practical class. Otherwise, thank you in advance, and be blessed as we continue viewing this video. I'll be coming up with more sample equations. This is now just the second sample equations in my video. Thank you in advance. Bye bye.